Hi, this is Mr. Max. So I am doing the inverse trig function, namely the tangent. So this is the third one of the previous two. So again, the information is similar. When we are dealing with the tangent function, and if we draw a horizontal line test, its inverse won't be a function. And in order for us to make that inverse to be a function, we have to restrict the domain. And you will see in a bit what interval we are using when we are talking about restricting the domain so that the inverse can be a function. Right, so the conventional interval that we are using is between minus 90 degrees to 90 degrees, or minus pi upon 2 to pi upon 2 radians. That is the principal interval value that we are using, and the domain, as you can see, is as I indicated, and also the range is infinite because this function goes up and down, right, forever. So the domain is positive infinity to negative infinity. Right, so when you are getting one particular value on a calculator, like for example, when we are talking about um, tangent, the inverse tangent of minus 2, that angle there, minus 2, that angle will be a negative angle. So it's very important for you to understand that when we are dealing with the tangent, we will be talking about the first quadrant and about the fourth quadrant. Okay, so that means we'll have an answer where we are dealing with a positive angle as well as a negative angle depending on the ratio that we are given. Another important fact is that sometimes that inverse tangent of x can be written as arctangent x or arctan x. It means the same thing, but it does not mean 1 over. Okay, so I could give you questions where I write arctangent of something, and then I rewrite that with that raised to negative 1 power, so to speak. It just means the same thing. Okay, so if we were looking at how the inverse function would look like given that restricted domain, now the range is going to be from minus 90 degrees to 90 degrees, or minus pi upon 2 to pi upon 2 radius. And the range, or the domain rather, the domain is going to be a value that goes on and on in the positive direction and negative direction. So it goes up to infinity. Okay, right. So this gives you an idea as to the possibilities that we are going to find. So this is the conventional restriction that we are using, that interval. So you need to understand when we're talking about the tangent. All right, and you will also realize that as you draw the tangent curve, it gets closer and closer to, for example, pi upon 2 or 90 degrees, but it will never actually cut through that. So it will never actually equal to 90 degrees or minus 90 degrees. That is why you see that the range here is values that are greater than or less than, but not or equal to. Okay? Right, so again, special angles, if we talk about a 45, 45, 90 degree triangle, which is an isosceles, again, if we say this unit here, or this distance to be 1 unit, then this is also going to be 1 unit because isosceles triangle, two sides are equal, therefore these two angles here are going to be equal as well. Using Pythagoras, you calculate the hypotenuse, which is root 2 in this case, and so when you have this type of information, you can actually, calculate or use these to find, say you have got some tangent of 1 upon 1, that just means the angle is 45 degrees or pi upon 4. Then the 30 and 60 equilateral triangle that I was using in the previous videos and also use here again, finding that height of root 3, you can now find the tangent of 30 degrees. Tangent is obviously always opposite. In this particular case, it's 1 upon the root 3, which is the adjacent. Okay, 1 upon root 3 or root 3 over 3 if you rationalize the denominator. You can also calculate the tangent of 60 degrees or the tangent of pi upon 3 radians. A tangent is going to be that opposite, which is root 3 upon the adjacent, which is 1, basically just root 3. So these two triangles where you can calculate some values are the only triangles that you should try to remember. Okay? Right, so I have got 4 questions here in the first exercise that I want you to try out. Again, I would say write them down, try to get to the solutions and see whether it makes sense. Also remember, if you're dealing with a cosine, cosine is going to be in the interval, the first and the second quadrant, that is between 0 to 180 degrees. The sine is in the first and the fourth quadrant, and the tangent is also in the first and fourth quadrant, which is from minus 90 to 90 degrees respectively. And this table is also very handy when you are trying to solve these particular questions. Alright, so if you had a go and you probably realize you got stuck somewhere, perhaps now is the best time for you to have a look and see what is it that I've done. Alright, so arctangent of 1 is just rewritten as the inverse tangent of 1 equals to x. Always let it equal to x. And then what does it mean? And it means the tangent of x is equal to 1. And that simply means tangent is 1 over 1, which is the opposite over the adjacent. So basically that is the values that we are dealing with. But hold a minute, we have a special triangle like that. So in that particular case, in order for us to find that particular angle, it's nothing but 45 degrees. And since that's positive, we're going to take that first quadrant. Okay, pi upon 4. In this particular instance, when it's negative, our solution should be in the fourth quadrant, which is going to make it a negative angle. So same scenario, and what does it mean? So it means that we are looking for, don't have to calculate that at h, because we don't have to do anything with the hypotenuse, and we can actually use the same triangle. We realize that our angle should be now negative, because in the fourth quadrant you're going back clockwise direction, remember, and the angle is minus pi over 4 radians, or minus 45 degrees. Then C and D, so C tangent, inverse tangent of root 3, again similar, just write that equals to x. And then what does it mean? It means the tangent of x equals to root 3 with a positive value. So we know that tangent is positive in the first quadrant. So I'm not going to worry too much about the fourth quadrant here because it's not a negative ratio. Right? So in this particular case, the tangent is the opposite over the adjacent. So therefore, using our special triangle, then we're going to use the 45, 45, 90 degree triangle. Again, you should be able, or in this particular case, we have to use this 30, 60, 90 degree triangle, because that's the only place where you find root 3. And you want to look for which angle is this opposite, and it's that 60 degrees or pi upon 3 radians, because here tangent is root 3 over 1, so that is 60 degrees. It's this particular angle here. Right, when you look at D, it could be confusing, but you realize that I always started my questions with let that stuff equal to x, but I cannot let it equal to x because I don't have an arctan or arcsine or cosine. I just have cosine. So I'm going to deal with the stuff inside. So I'm going to take that stuff inside and I'm going to say let that stuff inside equal to x. All right, and then what does it mean? It means the tangent of x is equal to 1 upon 3. So that means that the opposite side should be 1 and the adjacent side should be 3. So in order for me to be able to calculate the cos or the cosine, I need to find this height or this hypotenuse. Using Pythagoras, you realize you can get to root 10. Now what's important here, I have said that stuff there should equal to x. So I don't need to find the angle. That's not what we are doing here. Okay, so we're looking for that particular ratio. Because I said that that stuff be equal to x. So in order for me to use that x, I need to find the cosine of x using this triangle. And you know that cosine is nothing but adjacent, which is 3, over the hypotenuse, which is root 10. So the answer could be written as cos 3 over root 10, or you can rationalize that denominator as cos 3 root 10 upon 10. And this is how that question is asked. It's a little bit different than the rest, but it is relatively straightforward if you think about it. So I have a second exercise here. The question says find the value of x that satisfies the equation, the inverse sine of x minus 1 is equal to arctangent of 3, or the inverse tangent of 3. Well, here you can go ahead and use your calculator. So I'm going to use two different scenarios. I'm going to use where we have our degree mode as well as our radian mode. So first of all, before we have a look at this question, please remember that you need to subscribe to this channel, and then you'll also find a bell somewhere there, and click on that so that you can get all videos that I'm putting up, notifications of that as they come. Right, so when we work with degree mode, suppose your calculator is in degree mode, then this again, remember, arctangent of 3 is a calculator value, so you have to press your shift button, I believe, and then you get 71.565. And remember what it means. So it means that sine of 71.565 is equal to that stuff there, which is x minus 1. So it's from here, it's very easy. You just add 1 to the sine of 71.565, and you should get about 1.95. If your calculator is in radian mode, then when you press the inverse tangent of 3, you're going to get 1.249, for example. The condition, therefore, is the same. What does it mean? It means the sine of 1.249 should equal to x minus 1. So just add 1 to that particular answer, punch on your calculator, and you should get the same answer.